Hello! Let's make a third-person character controller with animations using Unity's new input system. So we'll set it up to use WASD movement. We'll have our camera set up on the mouse. We're not going to use cinemachine for this, we're just going to make it ourselves. We'll set it up to interact with the ground or colliding, so if you walk up on a wall, it won't clip into it. We'll set our character up to be able to jump, and if they land on a slope that's too steep, they'll slide. Or if they walk out onto a slope, then they'll slide down it. So seems like a lot, but it's actually not too much. Let's jump over into... I got an empty project here. The only thing I've done to this project so far is I've imported the animations that we're going to use, which is the Human Basic Motions Free Pack by Kevin Iglesias. I'll leave a link to this in the description. It's really cool. He's got a lot of good ones, so check them out. And the only other thing I've done is I've clicked these three buttons in my project window and added a command line argument of this. I'll leave it in the comments, but basically Unity 6.3 kept shutting down on me, and it was because of DirectX. So this forces it to go back to DX11, which DX12 just causes a bunch of issues for me. So if you're having issues with Unity 6.3 constantly shutting down on you, that might be why. Something to look at. So we are in a completely blank project. So first thing we're going to do is set up our character. I'm going to assume you have familiarity with Unity at this point, so you know hierarchy, project window, console, etc. Your window should look like this because I've set mine back to the default layout. The only thing you might not have is Package Manager, which is under Window, Package Management, Package Manager. But let's jump into it. So right click, going to create an empty object. This is going to be our player base component, so I'm going to call it player. I'm going to reset its transform back to 0 so that it's right there at the world origin. And under that, I'm going to add a 3D object of a capsule for now. This is going to represent the graphical elements. So a good thing in Unity is keeping the logic and the visuals separated. So we'll put all our logic on the player, and then this will just be a visual representation. For now, I'm just going to get rid of the capsule collider, and I'm going to move it up 1 on the Y so that it sits directly at the floor. If you're wondering why the pivot is in the middle, it's because up here we need to set it to the actual pivot. So the pivot of the capsule is here, but we're going to be moving the player from there. So we will add a component with the player game object selected. Let's go to add a component, and I'm going to add a character controller that I'm going to move up 1.00, there it goes, 08 on the Y. 1.08 because the skin width right here is 0.08, and if I set it to 1 when our character walks, he'll lift up off the ground that much. So you can either lower this or raise this. I typically just raise this. Personal preference on that. We'll add another of an animator, which we're not going to use just this moment, but we'll put it in place for when we do. And then the last one we are going to need for right now is a player input. This is what will actually register our inputs and send out our events when we, push buttons and stuff. Now this is going to need an actual input system. We're not going to use this one, we're going to create our own. So in the assets folder, I'm going to right click and create a new folder, underscore, and then all caps primary. This is just how I like to organize, just so that I know it's always at the front because of the underscore. Anything I import will be after it, and this is where I store all my prefabs, scripts, etc. So I'm going to right click and create 2 more folders, one that is prefabs and one that is for our scripts. Then in this folder, since our character is going to need a player input component, we will create input actions, and these will be our player inputs. Now with that player component or player object selected in the hierarchy, we can drop this right there. Now we haven't set anything up inside of it, so it doesn't have a default map and it doesn't know what to do, but we can double click and open it up, and it'll bring up this Player Inputs Manager, or Editor, whatever. Now here's where we can set our action maps, our actions, and the action properties. The action maps are the different control methods that our characters can have. So for instance, like in Grand Theft Auto, you have on foot, in car, flying. Those are different action maps. For this one, we're just going to set our basic to be a player action map. Now you'll see it already has one new action. There are 3 different types of actions, 2 that we are mainly going to work with. There's a value and there's a button. I'm not really sure what pass-through is yet. Haven't had a chance to, or haven't had a reason to really use it yet. So main ones we work with are value and button. Button is as it says. You push a button, something happens. A value is like a vector 2, so X, Y coordinates or movement input, movement logic. So this first one, we will right-click and we'll rename it to movement. We're going to change its action type to value. And then for this binding, we can set it to be gamepad left stick. And this will take all the inputs from our left stick and then apply it to our movement. Now for keyboard, we're going to need WASD. So if we click this little plus arrow right here that's on the movement, not this one, this will add a new action. But if we click this one with the little drop down arrow, we can add an up, down, left, right composite. And this is a 2D vector, or vector 2D, which has an X and a Y coordinate, up, down, left, right. Clicking this, we can expand that, and then we can set what we want to use. So if we click over here under path, we can hit listen, W, and then instead of having to search it out in the keyboard and do all that, we can just type what we want it to do. So for down, I'm going to listen for the S, listen for the A, and then listen for that one. Now we'll go ahead and set up one more action by clicking the plus here, and this will be our look input. This one will also be a value because we're going to be listening for the delta of our mouse. So click the binding path. We can't listen for this one, but if we click mouse, then we have the delta right here, which is basically the up, down, left, and right of our mouse. Now this doesn't save automatically. You'll see it has a little asterisk right here. That means it needs to be saved, so we'll click save. You can enable autosave, but I typically just do this. You can do that if you want to. So we'll go back to our player game object, and for the default map we can now select player. For the behavior, we want it to invoke Unity events, and these are events that we'll be able to call from inside the player script that we're about to set up. So you'll see it has a drop-down events. There's device lost, regained, and controls changed. These are just little significations, so if you need to change the UI based on a controller picked up, you can with this. But we are going to create some other events inside of that action map. So we'll go into our scripts folder and right-click, create a mono-behavior script. We'll call this one player. This is the one I generally use as like a general hub of different scripts, so I'll use it to get to my inventory from exterior unless we set it up as a singleton. But this will be where we set up the majority of our player movement, and then the camera logic will be inside of a separate script. We'll double-click and open it up. I'm using Visual Studio 2022 for this. It opened up off screen, hang on. So I'm going to delete everything inside of these first brackets. And now the first thing we're going to need is a speed that we want our character to move at. Now Unity has all the same variables and things that you would be used to in Unreal Engine if you're familiar with our other videos. So we're going to set it up as a float, but we're going to set it up with square brackets first. What are you doing? There it goes. And we're going to say serialize field. We'll make it private float, and this will be our move speed. And I'm going to equal it out to 4.5 to start. So serialize field exposes it in the editor, but allows us to keep it private. So we can still set it from Unity while keeping its accessor private to this script only, because we don't need to make everything public. A float is just any number with a floating decimal point, and then we name it with camel casing, so move, capital S, speed, and that's all we need for that one. So we will move on to our components. we will say private character controller. We'll call it controller. Then we'll have a private animator of animator. Now we will do another serialize field here. So serialize field, private transform, and this will be our follow camera. We're going to use the follow camera's transform to determine which direction we should move because we can't use our character. He's going to rotate when we move. So we'll use the follow camera's location to determine when we push forward, what direction does that represent. So we'll come down here. We will need two more. We'll need a private vector 2 for our move input, the actual WASD input, and then a private vector 3 that will be our move dir, which is dir direction. Oh, I thought I was going to sneeze. Sorry. Anyway, so we'll calculate our movement input based on our WASD, and then we'll combine it with our follow cam's transform to get the direction that we should move based on our move speed. If it sounds confusing, it won't be. Now we'll go down here and we're going to type in awake with a capital A, and then if we hit tab, then it'll automatically create the private void awake for us. If it doesn't, then you just private void awake like that, and then hit your curly brackets to do that. It's going to give me an error because I already have one, so I'm just going to delete that one. And for our controller, it is going to equal get component character controller. If it pops up and autofills for you, then you can hit tab and it'll just do. So like it says animator get component, I'm just going to hit tab and it autofills that for me. Do be careful about using tab because sometimes the autofill doesn't work exactly right, so sometimes it's better to just type it out yourself. But that is how we will get those two components. Since we've serialized the field of this component, we can establish it in the editor. Now we're going to come down and we're going to type update tab. Again, if it doesn't do that for you, just type it out, private void update. This is where our actual movement logic will be applied to our character. So we're going to type the name of the method we're going to use, which is calculate movement, and then we'll hit those parentheses, I think it's called, and then hit it with a semicolon. It's going to give you a red line because we don't actually have that, so we will set up private void calculate movement, and then curly bracket. So these are methods, and this is how we establish the logic for a method. So we can call it in the update function, which is how Unity registers its inputs. This runs every frame, whereas this is on the beginning of the game, and then there's a start that happens right before the game starts. Or this happens right before the game starts, the other one happens when the game starts, and this happens every frame. So when we calculate the movement, we are going to want to take our movement input and apply it to our move direction. So we're going to say move dir equals follow cam dot transform dot forward times our move input dot y plus follow cam dot transform dot right times our move input dot x. So this takes the forward and back of our WASD and applies it to the forward cam, or for the follow cam's forward direction. So if we rotate the camera, that will change. Same thing to the right with our A and D movement. That applies it by the camera's right vector. Now we're not going to want our character to be able to fly up and down, so we're going to set move dir.y equal to 0. That way, no matter which direction we're looking, he won't take up off the ground. Now we're also going to need to normalize the vector. So if we're moving diagonally, we don't want him to move faster because he's getting multiple inputs at once. We want it to just be one constant speed no matter how we're moving. So we're going to say move dir equals vector3.normalize, and then in the parentheses it'll be the move dir. That, yes. So after all this is done, now we have our move direction. We will say controller.move, and in the parentheses we put move direction times move speed times time.delta time. The time.delta time is basically your frame rate, so this is the time between each frame, because we don't want it to be applied every frame, otherwise your character will just zip across the screen light speed. So this multiplies it and makes it into game time rather than computer time. Now what we can do at the bottom, because we want our character to rotate in the direction that we are moving, we'll go up here and we'll do a private float of a rotation rate. I'm going to set that equal to 8.0f, or if you want to play around with it in Unity, you can serialize the field so that you can change this number easier, but for me 8.0 works. Now we're going to come down here and check to see if our move input.magnitude is greater than 0. So we'll do the if, and in the parentheses we'll check to see the move input.magnitude. The magnitude is basically a 0 to 1 ratio. So 0 means there's no input at all, and 1 means you've got full input. Doesn't know which direction you're pushing, but it does register that there's full input. And you can have anywhere in between there. So as long as it's greater than 0, we want our character to be rotating. That way if we stop moving, he doesn't automatically rotate back to face forward. So when we have movement, we want to set his rotation. So we're going to add a quaternion, which is how Unity handles rotations. And this is going to be rotate 2. We're going to set that to quaternion.lookRotation. And we'll just pop in our movement direction, because if our move input is greater than 0, our move direction will also be greater than 0. So we can use this to determine which direction we need to go. And then we will say transform.rotation equals quaternion.lerp, or linear interpolate, which will make it smoothly rotate between two values. And we'll go transform.rotation, so we're starting from our transform and going to our rotate 2. Then we will take our rotation rate and multiply it by time.delta time so that it rotates smoothly in game time. And this is almost everything we need in order to get our character moving. So one more thing we are going to need is an actual way of establishing our move input, because right now it's not going to do anything. And the way we're going to do that is with Unity events and our player inputs. We're going to come down here and we're going to set a public void movement input. And in the, just like we established the calculate movement method, we're going to establish another one. And in the parentheses this time, we're going to type input action dot callback context, and we'll just call it context. So we're calling a variable and establishing it, or a type, or whatever you want to call this. Basically, we're creating a variable and giving it a context, or a name, so that we can use it inside of the method. So we'll add our curly brackets, and then move input equals context dot read value of the vector 2. Not 23, there's only a few. So we'll call this from the Unity editor. It'll read the value of the context which the input action has. It'll determine, okay, they're moving in this direction. It'll apply it to that. It'll take this up to here. Since we're calling this every frame, it'll take those numbers and apply it to our move direction and then move our player. So if we Control S to save all this, we can go back into Unity. It'll take a second to compile. It does that sometimes. And then on our player, we'll drag our player's script and attach it, because we need to actually attach these to in-game objects when they're mono behavior. And now you'll see over in the player script we have the move speed variable that we can adjust and the follow cam that we can assign. Now right at the moment we don't have a follow cam. We do have a main camera, but that's not the one we actually want to use. We're going to right click and create another empty object, and we're going to call it cam origin, or cam start, or cam base, whatever you want to call it. Either way, I'm going to reset it back to 0 so that it sits right at our player. And I'm going to drag this main camera. I'm going to F2 to rename it to follow cam. I'm going to drag it onto that cam origin so that wherever I move that camera origin, you'll see this white over here. It follows. And then we will take in our player, the follow cam will be this camera origin point. For now, I'm just going to set that back to 0. We're actually going to move it up, but for right now, it's fine. So now under the player, we can go to that player input component, and where we've set its behavior to invoke Unity events, we can establish that Unity event. So if you click the events drop down, you'll see we have this player tag now because of the input up here. For the movement, we can click the plus icon. We can drag our player component directly into here, and from the function callback, we can drop down to player, and we can see our dynamic callback context of the movement input. So now if we hit play, our character's moving. It's hard to tell that he's rotating, but he is. Just to make that a little bit more visual, I'm going to go into the Kevin Iglesias folder, find that guy. And I'll delete the capsule. Just a habit to put a capsule at first, but yeah, you can see he's rotating and moving. And if I try to move right, he's going based on the camera's position. Yeah. So now we can helicopter. But now we need a way to actually move our camera. So I am going to go ahead and establish the camera view that I want, and what I have figured out from playing around with it is moving the camera origin up by 1.5, moving the follow camera back down to 0 on the Y, but at a -3 on the Z. I kind of like this camera view, seems to work pretty well for me, but you can play around with it whatever you want. And then we're going to set up a new script. So right click, create monobehavior script, and this will be our CamController. So give it a second to register, because if we try to open it up too quick, it'll just be like, hey, that doesn't exist yet. We'll go ahead and take this CamController and drop it on our camera origin, and then we'll double click and open it up. And now we can swap back and forth between the two, but we don't need to right now. So I'm going to drop over here. The first thing we're going to need to do, so the camera controller is going to be able to rotate, and it's going to follow our player component. We're not going to directly attach it, because when our player rotates, then the camera would rotate, but we want that to be independent. So we're going to serialize a field for a private transform, and this will be the follow target. This will be our actual player. Then we're going to do another serialized field private. This will be a vector3 for a follow offset. Now I know what my follow offset is going to be, so I'm just going to go ahead and do an equal new vector3 of 0f, 1.5f, and 0f. What that is the transform of my position of the camera origin that I have right now. That's why I went ahead and set it up here so I would know the numbers. But we'll serialize the field so that if you want to play around with it, it's a little oh, wrong one. Let me go ahead and close that so I don't get confused again. That way we can go ahead and alter it in script, but it'll default to this if you add a new vector. So you can make it default to something if you want to. So we need a private float of a follow speed, because we're going to also lerp this between positions so it doesn't just snap. And I found that 8 is a good one for me. You know, you can serialize that and play around with numbers to your heart's content. But we are also going to need so we're going to need to be able to apply rotation to a couple of floats. We're going to need a private float rot y, which is rotation y. Private float rot x. Since the movement is going to be, or the camera movement is also going to be a value, it's going to have an x and a y coordinate. Then we'll be able to add to these, which we add to our camera's rotation in order to affect it. Because if we just try to set it directly based on the input, then it won't get past 0 because x and y only goes up to 0 and 1. So we need to add or subtract from existing in order to keep the rotation we've already applied. On that note, we are also going to need a private float of a look limit. I'm going to set this to be equal to 45f. Basically, this is how high or low you want to be able to look. So that way you can't just rotate the camera in circles around your player. And then we'll need a private float of our cam sensitivity, which I'm going to default this to 20. Basically, it's the multiplier attached to the mouse in order to make it move smoother and quicker in game time. Because just like in the player movement, we don't want it to be in frame time, because it'll just zip around and make you nauseous. You forget time.delta time, you might make yourself sick. It's not unheard of. Alright, so now we can go down and we'll add an update. Just like in the other one, we need a private vector2 that'll be our look input. So just like the other one, we're reading a value from exterior in the Unity events, we'll do the same thing here. So we'll go ahead and set that up. So our look input will affect our rotation y and our rotation x. So we're going to set rot y, which is our up and down looking, to be minus equals our look input dot y times cam sensitivity times time.delta time. So I'm setting this to be minus equals. Basically, this is what a minus equals does is it subtracts and then sets automatically. So instead of having to set it or subtract the number and then equals blank whatever over here, it just subtracts and sets all in one node. But I'm subtracting because when I pull the mouse down, I want my character to look down. If you want your look inverted to where kind of like pilot controls, you pull down and they look up, make this a plus. So plus equals. So we're going to set rot y to minus equals look input times cam sensitivity times time.delta time. We're going to clamp this, so rot y equals mathf dot clamp, and we're going to clamp the rot y value between our negative look limit and our look limit. So this will take a negative 45 and a 45, so we can't look up too high or down too high. And then after that, we're going to take our rot x is plus equals look input dot x times our cam sensitivity times time dot delta time. This one we don't need to clamp because we could just let them rotate around the character as much as they want. You mainly just want to clamp your up and down so you're not looking too far up or too far down. Then we'll set our transform.local rotation equal to quaternion.lerp, and we'll take our transform.local rotation. Then we're going to create a quaternion.Euler. Euler basically means it will accept vector 3 coordinates. That's all I've been able to figure out. Quaternions have been kind of confusing to figure out, so that's why I haven't been going too in-depth into it. But quaternion is basically the rotation, and a Euler is a vector 3 coordinate inside of a quaternion value. And we can take our rot y, rot x, and then a 0. So the reason we're doing rot y here in the x coordinate and a rot x in the y coordinate is I'll take you inside Unity to show you. So if I have my camera origin selected, I don't want to rename it. And right here on X, that's actually up and down, which is our Y coordinate in scripting. And then the Y rotates around, which is our X left and right coordinate. So that's why So see that one. So that's why it's a little backwards right there. Now we are going to need to establish a rotation rate. So let's go up here and I'll add another private float rotation rate. That's not how I spell rotation. And we're going to set that equal to also 8.0. You can use the follow speed here if you want to. I like separating them out so I know exactly what each one is used for. And if I need to change one, I don't have to change the other. So we're going to say quaternion.euler rot y rot x0f, comma, rotation rate times time dot delta time. So that'll affect our the camera's local rotation. We don't want to affect the world rotation, we just want it to be relative to the character. So now we'll come down here and we'll add that public void look input action dot callback context, call it context, curly brackets, and then we'll set our look input equal context dot read value of the vector 2. So we'll Control S to save this. Go back into our project. Under cam origin, we now have some variables here we can adjust. The follow target is going to be our player base. It's not actually going to follow it yet. That's right. It'll rotate. It won't rotate because we got to go to our player and actually establish the input. I always forget that part. So click your player, events, drop down our player, and under the look callback context, we click the little plus. We can drag our camera origin over here. Even though it's not directly connected to the player, we can call events from it anyway. So we'll go into CamController and do our look input. So just to show you that it is working. Now I can rotate my camera. I can't look up too high, I can't look down too low. I got those backwards, but you know what I'm saying. So I can rotate around him, and if I look left and push forward, he goes that way, that way. If I pull back, rotating the camera changes the direction he moves, but you'll notice that the camera doesn't actually follow him yet. So we'll go back into our script, and underneath the transform.local rotation, we will set transform.position equal to a vector3.lerp, which we will start from our transform.position. Now we're going to take our follow targets, follow target.transform.position plus our follow offset. So this will get the position of our player in world and apply this to it so that it's not directly at his feet. It'll lift it up to where we have it. And we're going to have it follow him at our follow speed times time.delta time so that it's in game time. Control S to save, back over here, let it recompile. Now we have our follow target set up, so when I move around, you can see it kind of lerps, or it falls a little bit behind him. It's because of that follow speed. You can adjust that if you don't like how far it pulls away from him. If you increase the value of your follow speed, then that'll go up. Not crazy about how slow it rotates, so cam sensitivity, I'll bump this up to like, I'll double it, 40. Okay, so we got our character in and he's floating around with his arms out. Not exactly ideal, but he is moving, so now we can affect his animations. First thing I want to do is I want to go ahead and give him a ground to walk on so it feels a little bit more believable. So we'll right click and under 3D object we'll go to terrain. We'll just give him a little checker ground to run around on. Go into the scene view. No. Click our, come on now, there we go. I just want to pull it over that way a little bit. So now we can kind of get a feel for how fast he's moving on that ground. Woo! 40 might be a bit much. Yeah, that's fine. Yeah, so he's moving around for us. Can't jump, can't do anything, only can do helicopter meme. So we'll fix that. We will go create an Animator Controller for him. So this is going to go in our prefabs folder. We'll go ahead and drag our player into here so that it creates a prefab of him. Under the animator, we can click this, and that human model comes with two. These are called avatars, and they will apply the animation from one thing to another, basically. So we can click the human M model, and even though the animator's on the empty object, it'll apply it to our human model. But we need an actual controller, so we'll right-click, create, and under animation, we can create Animator Controller. And we'll call it Player Animator. And if we double-click and open this up, it should open up the Animator tab. If it doesn't, Window, Animation, Animator. So this is how we will affect the movement of our character, or the visual of our movement of our character at least. So this is where our animations will start. We'll create a state right here by going right-click, Create State from New Blend Tree. So instead of setting up a idle state, walk state, run state, etc., we'll just do it all inside this one. So we'll click it and rename it to Movement. We'll double-click and open it up, and we'll notice that it already has a value here called blend that goes from 0 to 1. Now if you remember our move input.magnitude earlier, that is how we're going to affect this. But we don't want it to be called blend. So if we click up here where it says parameters, we can click this once, wait a second, click it again, rename it to speed. Now the spelling is important here, so I've got capital S and then P-E-E-D lowercase. That will come into play when we get into the scripting side. You can't right click and do it, but if you do delete it, you can just click right here and then set up another one. This one is a float because it's going to have a decimal point. But you'll see it doesn't have any animations attached to it yet because the motion list is empty. So we'll create 3. We're going to add a motion field 3 times, and the motions are going to be under the animations using the male character. So we got idles, walks, and runs. And if you want to see what they are before you drag them out, a handy thing Unity does is if you click this, it doesn't show. But if you click the little expand arrow and click that green triangle, then you can click the play button to see what that animation will look like. So we can click our blend tree and drag it into the first slot because that is the leftmost slot. Then we got the middle one, which will be right here, and then the last one, which is way over here. So we're going to use our movement. The next one will be walk. Now there's 8 directional walk in this, but we're just using forward. So we want to make sure it's the one right there. It also says right here walk forward, whereas the other one's forward left, forward right, etc. So we'll just drop that here. And now for our run, same thing. Find the one that says run forward. I got it on first try all 3 times that time. Yeah. And then we can check it if we want to, just to make sure. Yep, that's right. Now we don't want it to automate the thresholds. You can if you want. It doesn't really change much. I just like to change this to 0.4 and 0.9 so that it reaches the full thing. It just makes it look a little nicer. If you're using an analog stick and you just barely push it, then it doesn't walk immediately. Now you will notice right now if you barely push the analog stick on your controller, if you have one connected, he's going to just take off running fully. We're going to fix that too. But we got this right now. We got our speed variable. We can go back into our script. On our player script, right here where we're calculating the movement, at the very bottom, we will say animator, since we already set that up, dot set float. And then in the parentheses, we'll put quotations, and then S-P-E-E-D, P-E-E, yeah. You want to set that to speed. You want it to be spelled exactly the way it is in your animator. Comma, and then for the 0 to 1 value, we can use our move input dot magnitude. And then hit our semicolon at the end. Now you don't want to do this inside your if statement because you want this to register even if your move input is 0. That way your character stops. But you'll notice something about setting it up just like this, which I'll save real quick and show you. We're going to come back and add to this in just a moment, but I want to show you something. So what you will notice is our character is going to go from standing still. Let's go apply that animator to our player. So we'll just drag it over into our controller slots. So what you'll notice now that he's actually got it is he will go from idle to instantly running to instantly idle, and it's very kind of off-putting. But if we go back in here and then we set our speed, we're using our move input, we can do another comma and say 0.2f, another comma, time.delta time. So this will be an interpolation rate for how fast it goes from 0 to 1, and it'll make it go in game time. So it won't immediately just take off full sprint, it'll actually have a little build up. So I'll show you what that looks like now. So it looks a little bit nicer. So one more fix for our movement input. In case you are using controller, you may notice that barely tilting it makes him run at full speed. We can use our move input magnitude here again. So we'll add another multiplication sign after our move speed, and we'll times this by our move input dot magnitude. Since it is a value between 0 and 1, if you got your analog stick pushed to, let's say, 25% of the way, it'll take all of this and multiply it by 25%. And since we're using that same one here, your animation will also match your move speed. I don't have a controller set up right now, but I don't know where mine went. But yeah, that's how you would get that. You would just take this move input dot magnitude, since it's a value of 0 and 1. If you're at full speed, it'll multiply it by 1, so it won't change it. But yeah, you get it. Back over here, now we got our character. We can look around, we can walk. We can't jump, and our camera has no collision, so it's going under the ground right now and all that. So that's what we'll work on next. We will work on, let's make our character jump. For that, we're going to need another player input. So we'll just minimize these, and then we'll add a plus right here. Jump. This one will be a button, and for the button, I'm going to use spacebar. So under path, listen, I'm going to tap the space. There we go. Now you can add as many as you want. So if you wanted to add, for instance, a gamepad, just click that path. You can either, if you have a gamepad plugged in, tap this and then tap the button you want to use for jump. I'm going to say, let's say, north, south, east, west. Okay. I always have to do the 4 directions, the north, south, east, west, in order to remember. But yeah, you can add as many different buttons as you want. Same thing for the look. So if you wanted to use the right thumbstick, we'll just add a binding, path, gamepad, right stick. Now what you may notice is the mouse moves at 1 speed and the right stick moves significantly slower for some reason. Not sure why, but you can add a processor to your right stick. So a processor is just something that's layered on top of your input in order to affect it. So we are going to scale a vector 2 since we know that this is a vector 2 input. And I've found that multiplying it by 3 seems to get it up to about mouse same level. But you can change these based on whatever you want. So we got our jump input, it's set to space. Now we need to go into our script for our player and actually set up all the variables and functions to make him register gravity and jump. So up here at the top, we're going to need a gravity rate, a way to determine whether we're on the ground, various things. So we will need a private float, which is our gravity rate. I'm going to set this equal to -10. You can serialize the field and play around with numbers. I highly encourage playing around with numbers. I'm giving you more of a basis on how it can be done, and then the fine-tuning is up to you. So we're going to need a gravity rate. We're going to need a way to check the distance from our ground. So private float ground distance, and for my case 0.3f seems to be good. We're going to need a mask to determine when our character actually does touch the ground, because we want certain things to register as ground and other things to not. So private, this is a layer mask, L and M are both capitalized, and this will be ground mask. Now you can serialize the field there if you want to. I prefer to just set it private and then determine it in the awake method. Then we are going to need a private vector3 for our player velocity. So this will be where we add the gravity rate to, and then we'll use this to determine the direction our character should be moving. So when we do our jump, we'll also affect this. We're going to need a private bool, which is on ground. Then we're going to need a private float jump height, and this will be 1.5f. So in the awake method, I'm going to set my ground mask equal to layer mask dot get mask parentheses, and I'm just going to set it to the default, because if we set like a ground layer, then you got to make sure you go through and everything you want your character to be able to step on has to be put onto that ground layer. It becomes a headache. The easier way I've found is to just determine that basically everything can be stepped on, because everything can really be stepped on, and the things you don't want to register, then that's what we take off. So it's easier to take off than to add on with so many things, Anywho, alright, so let's go down here to our update method, and we're going to create a new method that we'll call apply gravity parentheses semicolon. Now, just like the last time, gives us the red line. We don't actually have that yet. I'm going to minimize this calculate movement. At the very end, enter private void apply gravity exactly the same way, except for curly brackets. Now we have our on-ground boolean, but we don't have a way of determining that just yet, so we'll set that up first. So on-ground equals physics.checkSphere. So this is basically just an overlap sphere that will determine whether or not it's overlapping. It doesn't return any hit data, but it does determine whether or not it's overlapping anything within a layer. And we can set it to be our transform.position plus vector3.up times 0.2. So I'm doing that. You could serialize a field and add a game object to be the start point. I'm lazy, so I like to keep as much as I can in one aspect of this, and then so like if I can code it, I'd rather code it, and if I need to do game objects, then I'd do that, but I prefer to be able to just do this. So this takes our character's position, moves up 0.2 units, and it's just something that I've worked out. You can play around with values if you like. I recommend it. If your character is bigger or smaller, you might need to. And then we need a ground distance, which will be the ground distance we set up, and then a ground mask. So this will determine if anything in this radius is overlapping with anything on this layer, and if it is, on ground is true. If it's not, on ground is false. So if on ground double and sign player velocity dot y is less than -1.5 f. So we'll do an if statement to check if our character's on the ground, and if we've added enough to this to be less than 1.5. Or subtracted enough, I guess, since we're adding a negative. Yeah. Then we're going to set our player velocity dot y equal to -2. You could set it to 0, but then it kind of makes it feel a little floaty. So, and then that'll just keep looping this back and forth. I find that this works pretty well for keeping it a constant drop, so when you walk off a ledge it has an already good, pretty starting point. So if they are on the ground and the player velocity is below this, then we'll just say, alright, player velocity is to -2, and then it'll stop. Else, curlies, then we want to take our player velocity dot y and add, so plus equals our gravity rate times time dot delta time. Now you might think, why are we not subtracting if we're trying to move down? It's because the gravity rate is a negative. Now if you have your gravity rate set to just 10, then you would subtract equals gravity rate. And then at the end of this, we'll just say controller.move, and it'll be moving in the direction of our player velocity times time.delta time. So now we can go back in this one, and I'm just going to create a little cube for us to run up on, walk off of. Just to check to make sure that he is going up and down. That is a little floaty still. Oh, but that's because our character is on the default layer also. So let's set up a player layer. So highlight our player, go under layer, and see how he's set to default. We can add a layer by clicking here. And under user layer 3, I'm just going to set it to player. Highlight our player object, player, player, yes, change children. That way everything associated with our player is still a little floaty, but not as bad. And once we get animations, it'll look better. But we need to set up our jump input so that we can actually get them up off the ground. So we'll do that now. Public void jump input action dot callback context called context curly brackets. So we want to find out when the button is pressed and if our player is on the ground before they are able to jump. Now with the input system, when you push a button, you'll actually find out it pushes it 3 times at once. So there's a start, a executed, and then a canceled. We want to find out if the context.started has happened. That way it only happens once the button is pushed. Now if you want it to be when a button is let go of, then you can do on if context.cancelled, but unstarted seems to be pretty good for a jump, unless you're doing a charge jump. But we also want to find out if their context is started and on ground is true, because we don't want them to be able to jump in the air. So if context started and on ground, then we're going to set player velocity dot y to be plus equals mathf dot square root, because we need to take the square root of our jump height times -2 times our gravity. Brackies has a really good video on the mathematics behind this. But yeah, basically we just need mathf dot square root of our jump height times -2f times gravity rate. And that's pretty much it. Since we already got our controller.move up here, it'll automatically move our player based on that velocity. And we do need to go set up that input event on our player input. So under events, player, jump, we'll add that plus sign, and you can either drag the player script from here like that, or grab your player component and move it right there. Player jump input. Now when I jump, huzzah! You don't jump very high though. So, if you want to serialize your jump height field, I'm going to double this to, let's say, oh, that's not double, 3. Since he's kind of a stylized character, he's got some stylized animations, we'll make some stylized height, almost anime character jumping, I guess. There we go, a little bit better. You can see he starts off a little bit slow, and then as he falls further, it picks up speed. That's what we want. But we also want him to be animated. We don't want him running through the air. So we'll go over to our animator, go back out to the base layer, and over here we'll right click and create 3 states. So we're going to need one for when the jump starts, one for when he's falling through the air, and then one for when he lands on the ground. So we'll highlight each one and call it, let's see, jump. This one will be fall, and this one will be land. We'll set up some transitions between them so we can right click and make transition and connect them up like this. Just like that. And we don't need to worry about a transition going from here to here. We're going to tell it directly to go to this one, so we don't got to worry about too many different wires connecting all over the place and what have you. So, in order to get from jump to fall, we basically want our jump animation to finish. So we'll just leave has exit time right here. This basically says whatever animation is playing, let it play all the way through, and then transition to the next thing. For the fall animation, we don't want it to transition to land until they're actually on the ground. So the way we will do that is by setting up a bool parameter over here called onGround. And when that is true, then they'll be able to move from falling to landing. So instead of has exit time, we'll take that off, and for the conditions, we will set on ground to true. Now for the land to movement, we also want it to be basically when they're on the ground. We just want it to be a little hiccup in the falling and landing. But if they're moving, we don't want it to be too much, so we'll say has exit time is false. If you click these settings, you'll see it has a fixed duration, so you can make it to where this has a certain amount of time it transitions from this one to this one. You can affect that here. I'm going to leave it at 0.25 for now. But we want the condition to also be on ground is true. Now let's go get our jump animations. Animations, mail, movement, jump. Alright. So this is the human fall, just to make sure. Yeah, so that's my falling animation. The jumping, that's the landing, that's the beginning. So here's my beginning jump animation. It will go directly in the jump. And for landing, we'll go in the landing. So that's all of our systems set up. One thing you can do, if you wanted to, is you can make it to where it goes from movement to falling when on ground is false. That actually would probably be good. So instead of has exit time, it can go to this when on ground is false. That way, in case you walk off a ledge, it'll transition to the falling animation. But for the jumping, we're going to tell it to go directly. So we can do that by going into our jump input. And right after we have successfully affected our player's velocity, we can set animator.crossfade. Now this will take you from one state directly into another. Doesn't worry about transition lines or anything. And we will just, in the parentheses, inside quotations, tell it to move to the jump animation. This does need to match exactly your animation state, so you don't want any complicated names. You just want it to be jump, and then comma, tell it how long in the normalized transition duration, so I'll say 0.1f. And then just like that, our character will go straight into his jumping animation, as long as that matches. But he's not going to come out of it, and I'll show you why in just a second. So he does do into his jump, but you'll notice that he's kind of, right? And that is because while we have set the Boolean in the animator, we actually are never changing it. So we have our on ground here, and we have the on ground in the animator, but they don't know anything about each other just yet. So down here at the very bottom, after we've done controller.move, we can say animator.setBool, and in the quotations, we'll set it to be the on ground, comma, set it to our on ground value. This also has to match, remember, it has to match exactly the spelling in your animator. But now, he walk, he run, he jump, he fall, and he land. Exactly what we want. Oh no, what seems to be the matter? This would be where that skin width of your capsule comes in. So you'll notice in the scene view, his actual collision is fairly wide. This is also the skin width, but also the radius of it. So I'm going to set my radius down to 0.25, maybe 0.3. And that'll make it a little bit more reliable for determining our actual landing coordinates. You want it to be just basically around his body. And if we walk off the ledge, yeah, that's cool. So let's set up just some, I'm going to create some little cubes real quick. Neat. Huzzah. So that's cool. But the camera does not interact with anything yet. So it will clip through walls, it'll clip through anything, it'll clip through the ground. So we'll work on that now. So we will go into our camera controller, and we need to set up a couple more things. So we're going to need another serialize field, private game object, and this will be our cam object. So transform and game object are fairly interchangeable, but I personally will change which one I'm using depending on what I need it for. So if I'm referencing a specific object, I typically use game object. If I'm trying to follow something in the world space, then I'll use the transform. It's more of a mental thing for me, I guess. You can use, like, you could make the follow target a game object and then just get follow target.transform.rotation, which is pretty much what we did. Or do game object.transform, but it's the same thing, but it's just more of a mental thing, I guess, for me. But we're going to need that cam object. We're going to need a private vector 3, which is our cam default position. Private float, which is our follow distance. I'm going to set this to -3. And then we'll need a private layer mask called ignore mask. So basically anything we want the player to ignore will be on this mask, which is basically just going to be our player. We don't want our player affecting our own camera, otherwise, it can mess with play. So at the very bottom, after we're affecting the camera origins transforms, we want to set the cam object.transform.local position equal to a new method that we're going to create called check for obstructions. So we want to make sure it's the cam object, and we want to affect the local position and not just position like this, because we're not moving it in world space, we're moving it in relation to the parent object, which is the cam origin or the cam controller. Basically, we want to fire a ray trace out from the camera origin base to where the camera's at and see if there's anything in between those points. And if there is, then we set the camera up a little bit further. And if there's not, then we move the camera back to its default position. So we'll set an awake method to set the default position equal to camObject.transform.local position. We will also set our ignore mask equal to layer mask.get mask, and we'll set it to player. Now we'll go ahead and set up this check for obstructions. Private, instead of void, this one is actually going to return a vector3, so private vector3 check for obstructions. Like that. So now you'll see we have a red line here, but we don't have a red line here. That means this is registering that there is a method, but this is saying that it's not returning the vector3 that it's expecting it to yet. So we need to set up everything. So what we will do is we will say if physics.raycast, which a raycast is just a ray trace, line trace, sphere trace. They're, if you're familiar with Unreal Engine, we did a lot with sphere casting, ray casting. And we're going to take the transform.position, because remember, this camera controller component is attached to our camera origin and not the follow cam itself. So we're going to take the position of this and shoot a ray in the direction of this to see if there's anything interacting. So we'll take our transform.position and we'll take our transform.forward since we're shooting a negative number, it'll go from the transform forward backwards since it's negative. Right here we want to do out raycast hit. We'll call it hit. So this is going to take whatever information it gets from the raycast, if there is one, and take it and put it into our hit variable that we can use. So we'll out a raycast hit, and then it will be our follow distance, is how far we want the max distance to be. And then for our layer mask, we will hold shift and hit that tilde key, which is on this keyboard, it's over by the 1 on the main number pads, but it's that little squiggly like that, and type in ignore mask. So that tilde key right there means anything but this mask. So you can do a layer mask that is specifically for a specific layer, or this that ignores a specific layer. So that's why I called it the ignore mask. So if our physics raycast hits anything from our camera origin backward, because we're going transform forward in a negative direction, we'll take the hit information, as long as it's not on that mask. Then we will say get the vector3 of a hit point, which will be equal to our hit dot point. You might think, why don't we just use this hit dot point if we got it? It's because it's going to take it in a world space and we need to convert it to a local space. So we'll take that hit point and convert it. So we will do hit point equals transform dot inverse transform point of our hit point. So this, if you look, it says transforms position from world space to local space. So it will take the world space and transform it to a local space according to the component that this is attached to. So relative to the camera origin. And then we can return our hit point. And that can be what happens if we hit something. Else, we just return default position. So that'll be how we check for obstructions. Right. So now we do need to set up the cam object. So we'll set the follow cam to be our cam object on our cam origin. So now we can move and it's not interacting. Why you no do the things? So we'll say instead of doing transform.forward a negative, we'll do a negative transform by a positive. So that should take the reverse of a transform.forward and go out that far. Let's see if that was the fix. I always get that one confused every single time I have set up a ray tracing camera. Oh, there it goes. So now it's moving forward based on whether it's hitting something. You will notice that we are able to see what our character's thinking, and he's quite the airhead, it seems. But we are at least moving our camera up. If you don't like the way your camera clips through your character, highlight your follow camera, and under clipping planes we can just set that to like 0.1. You can go lower than that, but I just didn't put it at 0.1. And then, no clipping. Unless you get like right up on it. But, you know, at that point, what are you going to do? So now we can run, jump, he's animated fully. Huzzah, it's working as intended. There's one more thing that we will need to be able to do. So, let's say your character finds a wall that they can jump up. Now this seems like it would be far too steep to naturally walk up. And in fact, if you try to walk up it, you can't. But the character will stay there, and you will be able to continue to jump. What we can do is we can actually calculate the angle of this, and then if it's too high, make our character slide. So let's do that now. So we'll go into our player controller, and we are going to set up a couple more things. Actually, I think it's just one more thing. It's private, float, and it'll be angle tolerance. I'm going to set this. I'm going to set it low for now, just for demonstration. But this, basically, you don't want your character to be able to walk above this angle. So I think 55 or something is normal, or 50, I forget. But basically, they won't be able to stand on anything above that. So when our character is on the ground, we want to determine what the slope of that ground is, and whether or not they'll be able to walk on it. Sorry. So we're going to create a new method, and we'll call it check ground angle. We are going to set this in our apply gravity if they are on ground and player velocity is less than this. You can put this down somewhere else or just directly in the update, but we only really need to know what the ground is like if they're on the ground. So, I mean, yeah. So right here after this, we'll create a little space, and we'll do a private void check ground angle, curly brackets. So if they're on the ground, then we want to shoot a line down from their position and see what the ground angle is. So we will do a if physics, it's not how you spell physics, dot raycast, and we'll do our transform dot position plus vector 3 dot up times 0.2. We're going to shoot it down, so we want to say transform dot down. That's not a thing. Transform dot up, and we'll just shoot it in a negative number. There is a vector 3 dot down, but I don't know, let's see, vector 3 dot down. Yeah, we'll do that. The max distance, let's say 2 units. And we don't really need to worry about, well, we do need to worry about, let's just do our ground mask, because we're only checking if we're on the ground. We don't want it to affect our player. So if physics raycast from our position up 0.2 units in the down direction, in the direction of down, 2 units hits anything that's on the ground mask, then we will use that information. So we do actually need to come back in here and do an out raycast hit, and then we're going to do a float ground angle is equal to is equal to vector3 dot angle of the transform dot up to the hit dot normal. Just to show you what that does, let's do a debug.log of our ground angle. This is partially just to make sure that I've got the right transform going so far, because I'm pretty sure it was transform.up, but I get those confused. So he's on the ground, and right now it's saying 0. That's what we want. So if he jumps up on this, then it's 57 degrees, and that is not what we would want to be able to walk on. So we would want to shoot a line down and figure out what the angle is from here to here, and then move in that direction. So in order to do that, transform.up and hit.normal was the right one. So if physics raycast hits has the ground angle, if the ground angle is greater than our angle tolerance, meaning it's higher than the floor we are expected to be able to walk on, then we are going to do a vector3 of a slide direction. That is going to be equal to vector3 dot project on plane. So this will take a starting point or a starting direction, move down, and then project the angle. So we want to say the vector is the negative of the transform dot up and the hit dot normal. And then we want to tell our controller dot move in our slide direction times, I'm just going to set it to 8 for now, times time dot delta time. Now you want to say negative transform dot up, because if you do transform dot up, it'll project upwards, but you could do vector3 dot down and it'll be the same thing. Yeah. So let's hop back over into our game. So now you'll see, if I land too high up, then he just comes right back down. Now there is a little bit of a gap right here to where it doesn't go all the way down, but it's because that line is going straight down and it's hitting that 0 angle, so it's not registering. That'll be just, one of those things. But I can jump up here, I can walk on this one, but if I walk over there, then he falls off. And if I sculpt up my terrain a little bit, is this it? No, yes. So now there should be so now he'll slide any direction that's too steep for him to walk on. Alright, so there we go. And that's... Oh! I had my controller, but you know what? Here. My microphone cable has gotten very weak, so I was worried about unplugging and plugging it in, but let's see if this will work. Hey! Alright, so now when he walks with just the the stick, we can see that he walks slow, like he's walking away from an explosion, but he's a cool guy, so he doesn't look. And if I tilt the stick all the way, then he walks fully, but his animation and speed will match how light I push the stick. So yeah, that's what we wanted. Oh baby, that's what I've been waiting for. So yeah, there's how you can do all that with Unity's new input system. Get yourself a third-person character controller and all that jazz. So if you have watched this all the way to the end, you may wonder, why suddenly back after a year, and why suddenly shifting over into a different engine? That is something that I will explain in a follow-up video if anybody's interested to know, but to summarize, it was basically 45 puppies, lost my computer for a while, and had a baby. So, lots of things. 45 puppies from a few strays that kept giving birth under our house, and then they're babies. I can't just abandon them. I had to take care of them. So we had to. That took some doing. But yeah, so I'll explain why I switched over into Unity in a follow-up video if anybody cares to know, or if not, just stick around for more fun Unity and Unreal Engine tutorials, because I like Unity now, and Unreal Engine is a mainstay on the channel. So yeah, thanks for stopping by. Bye. Oh, I never stopped recording.